Thank you to everyone for attending the Industry Leaders Lecture Series, Cloud-Based Security, Zscaler, and the New York Tech Collaboration. This hour-long webinar will be recorded. There'll be an opportunity for all questions to be answered after the presentation. Leave your questions in the Q&A chat box below. Now I'd like to present the Dean of College of Engineering and Computing Sciences here at New York Institute of Technology, Dr. Babak Beheshti.
Thank you, Sarah. Hello, everyone. It is my pleasure to welcome everyone to the second session of the Industry Leaders Talk Series in 2022, hosted by the New York Institute of Technology's College of Engineering and Computing Sciences. My name is Babak Beheshti, Dean of the College. Before we get started, let's ask the audience a couple of questions so that we learn a bit more about who is attending this talk. The first question I have, and once I read the question, please use the raise hand feature at the bottom of your screen to respond, and we'll tally the results and announce it to everyone. So the first question I have is that how many of the attendees are students? So if you're a student, please raise your hand.
We have two.
Two, all right. Fantastic. And the second question is that out of the audience, how many of you are joining the webinar outside of Long Island and New York City metropolitan area? So if you're outside of Long Island and New York City metropolitan area, please raise your hands.
We have 12.
Wow, so that's very good. So thank you everybody for joining us from near and far. Obviously a talk that is very much appropriate to the times. We'll get started with that without any further ado. So this talk series is co-sponsored by the IEEE Region 1. Our thanks go to Dr. Greg Godowski, the IEEE Region 1 Director. I would like to thank the College of Engineering's Dean's Executive Advisory Board, particularly its chair, Dr. Robert DeFazio, who has been instrumental in organizing this series. Please note that this talk will be recorded and the recording link will be made available to you in a follow-up communication. Today's industry leader talk is titled Cloud-Based Security, Zscaler, and the New York Tech Collaboration. This talk is given by Mr. Larry Karantzios, Senior Pre-Sales Engineer East at Zscaler Incorporated. Larry Karantzios is a Senior Pre-Sales Systems Engineer at Zscaler. Karantzios is tech lead in migrating traditional company on-premise network security solutions to a digital transformation cloud internet security solution, along with secure remote access in a zero trust environment. Before Zscaler, Karantzios worked as a senior pre-sales engineer at Fortinent, designing network security data center and internet access solutions for the banking and financial services sector. Karantzios has also worked for Juniper Networks, leading technical sales in computer network security opportunities in the global banking and financial institutions. Without any further ado, I will pass it to Larry. Larry?
Thank you, Dean Beheshti, and hello, everyone. Thanks for joining, and let me share my screen, and we get going. So before I begin, just one more question. How many in the audience have heard of the term Secure Access Service Edge and Zero Trust Network Access? Just a quick question before I go.
We had 9 people raise their hand.
Okay, good, because this is primarily what this presentation is about. So let's get started. So the agenda today, what I'm going to cover is we're going to cover cloud security, as the title says, zero trust, the history and the market overview. What's causing this to take place? Next, we'll talk about the 2 topics in this presentation, which is the Internet Access, Secure Access Service Edge, and Private Access, which is the Zscaler Zero Trust Network Access. And then at the end, we'll spend some time about discussing the New York Tech and the Zscaler Industry Partnership, where the students can join the Zscaler Academy and get certified as cloud administrators to manage policies in the cloud. Okay, so how do we get here? with the market forces. If we look at the timeline, back in the 80s, we had the mainframe. Then in the 90s, we went to client server architecture. In 2000, internet became apparent that we needed an e-commerce mechanism, and it just took off. But security wasn't in mind when the internet was built. So therefore, we had to put security devices in place to prevent any attacks, hacking, and breaches. Then around 2010 and beyond, we went to cloud. You saw Amazon, Salesforce, Azure, Office 365. Everything started moving to cloud. And now, the last few years, with COVID, remote internet access, remote access, work from anywhere became apparent, and it was a must for everybody. So it caught a lot of companies off guard, especially because they had the legacy technology where you had the VPN IPsec going back into the major data center hubs to get access to the applications. And this created a lot of problems. So this is the threat that's out there. So the threat is real. There's a lot of attacks, data breaches, and hacks. This is just a site which shows you a bubble chart of what's happening the last recent times here. You go to informationisbeautiful.net and you'll see this live bubble chart of how many breaches occurred and in which company it happens. You can see Facebook, Microsoft. These are companies that have a lot of money to put in security, but yet they still have breaches. So introduction to cloud, right? Now, what is cloud? Cloud is, you heard the definition where cloud is just servers located somewhere outside your perimeter. Primarily, if you group cloud, it falls into three categories: infrastructure as a service, platform as a service, and software as a service. And depending on which category you fall into, some areas here you would manage and some the vendor would manage. In this talk today, I will strictly talk about software as a service. We'll concentrate on this bucket right here. Now, let me start with a quick overview how we got here with the legacy network architecture and security to put things in perspective. Now, the DC, the data center, was center of gravity back in the 90s when I first joined the financial companies of Wall Street to design DMZs and internet access. So what a typical global company had was a hub and spoke environment, few data centers, maybe 3 to 6 data centers around the world, in different continents. Here you see the example in the US, Europe, and Asia. And everything was connected by MPLS, point to point. Really, there was private networks, so there was really no security. There were some firewalls across here, but not too many. The minute you have internet access, so you had a pipe going up to the internet here, that's when you needed to put that security stack in place, which consisted of multiple point devices to prevent antivirus, perform URL filtering, do SSL inspection, load balancing. And you had to put this in every location around the world, wherever the internet access ISP lines were. Now, the world has changed. Applications are moving to cloud. And now, if you don't move into the digital transformation, you're inhibiting business from growing. The perimeter is gone now. People work from anywhere. So you can't force people to work from home to VPN into the hub where the IPsec VPN is to go out to the internet again so they can get inspected. What happens is it's slow, especially when they go into Office 365. And a lot of times, if you don't have controls at the endpoint, the user will just turn off the VPN and go direct. There have been a lot of cases where customers, users are complaining, and all of a sudden they're like, all right, we're going to go direct. We're going to turn off the VPN. So unless you enforce that, you have the likelihood of a breach happening. So you have a risk because if you go direct without the proper security controls, then a virus might come in. The minute you come back and connect to the internal network, then you have lateral movement and you get infected and all your data is compromised here. You get higher costs because you have to add more devices as the risks evolve here. And now we have nation states that are actually carrying out cyber attacks, which is very hard to control. So let's take a look at the classic hub and spoke network. So you had the outbound stack for your firewall, IPS, URL filtering, antivirus, data protection, SSL inspection. And then you have your inbound stack for the VPN internal access. Let's zoom in a little bit on this internal access. What does the data flow look like? Typically, you'll have your stack here. You have your external users located somewhere, here in this case in Boston. They want to access an internal app. They go in, they connect to a VPN concentrator, which has an IP exposed on the internet, which is liable to DDoS attacks. And if the app has moved to AWS or Azure, then there's a site-to-site VPN internally. And when the user wants to access that app, you'll have to go all the way in through the IPsec tunnel and then back again. So you get this trombone effect, which causes a lot of user delay and experience, and the users aren't happy. Now, to implement this, it takes months to get this infrastructure up sometimes. And this proved true during COVID, when a couple of years ago, when companies went work from home, they weren't prepared for this. Usually when you get a VPN, you figure maybe 50% of the workforce will be out or 25% will be out. So they didn't have enough licenses to sustain 100% from home. So in countries like China and other countries where you had to ship gear, it would take months to ship gear there. And that's when a lot of customers came to Zscaler, where we can spin up cloud VMs for Zero Trust Network Access to accomplish what the legacy VPN did and provide Zero Trust Network Access. Plus, this is complex to maintain security. You have to put ACLs on firewalls, and there's a lot of places where you can make a mistake here. It's very cumbersome. I don't know if anyone has done this, but it's very hard to keep track of all the policy changes and what users come in and what applications they access, because here you place a user on the network, you get an IP address, and if you don't have the proper controls, security controls in place, then the user can go lateral movement to any server and try to get in, just do brute force attacks, and there is no way to stop them unless you put very granular rules, which take a long time. And users become frustrated because of the time, especially if the concentrator is on the other side of the country. There's a lot of latency for applications to go back and forth. So how do we solve this, and what's the next step, and where is the future going? So the reason I asked if anyone heard of Secure Access Service Edge and Zero Trust Network Access, these are the two architectures that are you hear today in the news and what the analysts and government is suggesting that everybody go to. So here's the Zero Trust timeline. Back in the early, late 90s, 2000s, was the first attempt to isolate the servers from the users. You created network segmentations with VLANs, and you had some access lists. Then 82.1x came around, network access control. But to implement this effectively, it was very hard again. Then back in 2004, we had the Jericho Forum that said, we need to dissolve the perimeter. We have to have a different way of securing our core servers. Then Forrester coined the term Zero Trust in 2010. Google was the first one to actually publish Beyond Corp, which is actually a Zero Trust network, but the only company that could do it because they have a lot of resources. It's a network built by engineers for engineers. So to build what Google did will be very hard for each company. Then Gartner redefines the term ZTNA and coins SASE, Secure Access Service Edge, to 2019. NIST publishes Zero Trust Access. Gartner introduces Secure Service Edge again in 2021, and the government Federal Trust Strategy is published in 2022. So that's how we got here. So if we look at the Gartner, what the analysts are saying, what the Gartner report says, the future of network security is in the cloud. You can't have legacy security castle mode anymore and backhaul traffic. It's not going to work in the new world. What they recommend is having all the branch offices forward traffic direct to the internet and have some type of security in the cloud to make sure that the destinations where users are going are allowed and are inspected by doing SSL inspection. SSL inspection is key because lately, about 90% of internet traffic is SSL inspected. So if you don't break out this connection and look what's inside, you're blind to the viruses and other content that could be harmful to you. They recommend compute at the edge, not in a core data center. So in other words, when you hit the edge, you first hop from your router to the internet, compute should be there, not be forwarded to some type of compute data center somewhere else. And I'll go into this a little bit later. And inline traffic inspection, SSL inspection is a must. You must have that enabled. Believe it or not, I've been doing this a number of years now, and I still find companies that they do not have SSL inspection turned on. They rely strictly on the URL filtering by DNS names, which is not very effective security. Then when we look at Zero Trust Network Access, that's accessing applications from anywhere, coming back inside or in the cloud, wherever this application occurs. What they recommend is not, they need a new design for a legacy VPN. In other words, there's no more VPN. You don't want to put an IP address on this user so they can have lateral movement. Applications should not be exposed on the internet. So a hacker should not be able to access an application. Applications should be hidden from the internet. And you need precision app access after authentication. So first, we're going to shift security from network to user identity. Once you identify the user, who the user is, he's part of some Active Directory, he's part of a group, a department, and based on that, you'll make a decision what application she's allowed to go to. And this is mapping a user to an application on a per app basis. So you have a TLS encrypted tunnel created on demand based on access for any application. And then once the user terminates the application, the connection gets brought down. And Gartner states that network security architectures that place enterprise data center at the center of connectivity are an inhibitor to dynamic access requirements of digital business. So they're saying the castle and moat doesn't work anymore in a new cloud environment. This is the new architecture where you have network as a service and security as a service all combined into one. You have your users, machines in the middle, access anything, anywhere from any device, whether it's corporate or BYOD. And depending what type of devices, there's posture assessment to see if it's a corporate device, you're allowed to access a certain number of apps. If it's not, if it's only a BYOD, then you can set policies to say maybe you're only allowed to go to mail or specific content on the web. So now you have your users on the bottom here, using any device, any user, anywhere, trying to reach applications that might be located externally or internally. And the new architecture now is this, where first, before you, in the old days, we used to put a VPN connection, you get an IP address. Here, first thing you do is you challenge the user to identify himself. You find out who is the user, is he an employee, is he a partner, what device are they using. If you want to use dual factor authentication, you can. And once you establish that, then you ask, can we trust this device? If it's a corporate device, then you trust the device, all the security in place, all the antivirus up to date. Yes, okay, now you can go and access whatever applications you're allowed to based on your group, department, or user based on the policy. And what is the risk now? Of course, any connection that goes through this proxy has to be inspected, including SSL. And where you're going, based on the policy that you set, you'll either be allowed or denied to go. And once everything clears, then the established connection occurs, and you have connectivity through a Zero Trust Exchange. So let's look at the Zscaler SaaS CZDNet solution. So what Zscaler created, we started back in 2008. First, we started with a proxy, and then we added all the other services. So now we have a Zero Trust architecture with Zero Trust Exchange in the middle, and we make cloud a safe place to do business. There are 4 integrated and comprehensive solutions Zscaler in the Zero Trust Exchange. You have Secure Internet Access, SaaS, where you have cyber threat protection, data protection, local internet breakouts, Office 365, SD-WAN falls into this area. This is Secure Access Service Edge. Private Access, this is the replacement for the classic VPN. Remote app access without VPN, mapping the user. After you identify the user, get the Active Directory parameters where they're located based on a policy, you allow or block that user from accessing the application, strictly mapping a user to the application. Next, we also have digital experience where we have visibility. Since we have an agent at the endpoint, we have the proxy in the middle, and we have visibility to the traffic going through us. So we can get a hop-by-hop latency count where the bottleneck is, or if there's a problem with the CPU on the machine, that information gets collected by the agent. A lot of times we find out that users' Wi-Fi signal is very low. They haven't changed their device since 4 or 5 years ago, and now with COVID, they're trying to push the data out that the router at home doesn't support anymore, so they had to change the router. So you can actually see that on a Wi-Fi signal. So sometimes you'll see 40% signal, or if the person moves away from the access point. So it's a quick way for the support operations department to isolate an issue, because now you don't have control of your internet transport network. In the old days when it was castle and moat, you have control everywhere, so you can actually log into the routers and do a hop-by-hop count and see where the bottleneck is. Now, you don't own the internet. However, with a proxy in the middle, like Zscaler, you do have visibility, and you can actually isolate problems. And the last quadrant is secure app workloads, where you have app-to-app communication between cloud to cloud or data center to data center. So Zscaler has the largest inline security cloud in the world. There's 150 data centers across 6 continents. You see the locations here. We peer at internet exchanges. What that means is all these POPs are sites like Equinix, where all of our partners peer. So Microsoft Office 365 peering is there. So when you hit Zscaler and you want to go to Microsoft Office 365, usually it takes 1 to 2 milliseconds because the rack of Microsoft is in the same building. So no matter where you are, you'll hit the nearest Office 365. And as you can see at the bottom left here, we have many certifications, and recently we got the High Authority FedRAMP certification, so we can do business with the government now. We're very focused on what we do best, and that's security, having a Zero Trust Exchange. We have a platform, and we have to integrate with other platforms in order to have a blueprint for a fully digital secure transformation. So partners like identity management, like I said before, when you identify the user, what we do is when the user first logs in, hits the proxy, if you're not authenticated, we will redirect you to go to your local identity management provider, which could be Microsoft Azure, it could be ADFS, it could be Okta, Ping, any SAML provider out there. They will handle the authentication and just pass parameters like user, group, and department to Zscaler. And based on those policies, we will do management for policies. Then we have the endpoint management. So you can manage the endpoint devices like iOS devices, Android with Microsoft Intune, Carbon Black, CrowdStrike. For branch routers, all of the SD-WAN providers support forwarding traffic to Zscaler by either GRE tunnels or IPsec tunnels. So you have a thin branch sending a default route to the internet for all 000 traffic, and any internal traffic that you want to send to data center, you can also use IPsec tunnels on the SD-WAN. So you can do east to west going through SD-WAN, but north-south goes through Zscaler. And we have a full proxy stack in the cloud, no matter where you are in those 150 data centers in the world. Cloud providers on the right here, we partner with Azure, AWS, VMware, Google Cloud, Office 365, and also logging. We have our cloud logs all metadata, so you get all that information. It sits in our cloud for 6 months, or you can actually have a VM that could have an outbound connection to us, TLS connection, and then we can stream data to your local SIM, whatever that might be, Splunk, Creator, or whatever it is. As you can see, we're well received by the analysts. Here, this is the 2020 Magic Quadrant. We're the leader, and we've been #1 since this first came out. And as you can see here with COVID, we like to socially distance ourselves with our competitors. Now this year, Gartner changed the secure gateway to a new Magic Quadrant called the Secure Service Edge. This is from Secure Access Service Edge that I mentioned earlier. So this is the new quadrant they're going to monitor. And again, you can see Zscaler is at the top. We're the leader again. So what are the attributes of a zero trust architecture? First, you need zero attack surface. The legacy infrastructure with firewalls, VPN, published on the internal can be exploited. It could be DDoS. So when you have an IP address sitting outside of the internet, visible to the whole world, they can have DDoS machines just bombard you with traffic and bring the site down. In a zero architecture, apps are not exposed to the internet, and you can't attack something that you can't see. So we hide that behind the Zscaler trust architecture, and I'll show you a little later, a few more slides, how this works. You connect the user to an application, not to a network. The network now is just a transport. You don't care what the network is because there'll be TLS tunnels or DTLS tunnels going across encrypted from end to end. So it doesn't matter where you go through. No one can peek inside that tunnel. Proxy architecture, not a pass-through. This is very important. A lot of people would insist that next generation firewall is just as good as a proxy. That's not true. Proxy is a lot more secure than a firewall because a firewall is limited to a certain number of packets that you can look at a pass-through. Where a proxy is, you terminate the connection, you open up another connection, and you check fully the whole content of the file that goes through. And next thing is the multi-tenant architecture. VMs that are single tenant appliances in the public cloud still have to have a serial pass-through. If you have a VM for antivirus, a VM for SSL inspection, you still have to go through a serial connection to inspect everything. And this it doesn't work in a cloud environment because it's something like asking yourself, would the Netflix build streaming with DVD players? You need a cloud native multi-tenant architecture like Salesforce and Workday to be efficient. And you need secure access service edge, SASE. One thing you'll get out of this presentation is that SASE and ZTNA are the next generation of security for zero trust access for cloud. Here, policies enforced in the legacy environment is enforced in a couple of dozen data centers around the world. So even though you have access to, let's say, 100 entry points, your compute data centers where the firewalls are and the security stack, they're only at a certain number of areas around the world. So no matter where you go, you still have to send the traffic back to those compute data centers to do the security inspection. In a zero trust architecture, all your policy enforcement is done at the edge. So all those edges that you saw before, the 150 data centers, you got to have all the security stack there. In other words, connection terminates there, go through security inspection with all the engines, and then the traffic goes through where it's supposed to go. Here's a video comparing the pass-through versus a proxy. As you can see, packets go through, and you only have a limited time to inspect here. So you only have a limited buffer that you can actually inspect. Now, you don't know what's in the trunk. As you saw that, you just went right through. In a proxy architecture, you see the traffic gets stopped, inspected, placed in another car, and another connection gets opened. So here, the advantage is when you have a file coming in, you can inspect the full file before you allow the connection out. Where in the firewall example, you only have a limited buffer of the file that you can inspect. And then you got to say, well, what should I do? Should I let it go or not? I inspected maybe 10% of the file, and then make a decision. Here's what I was mentioning before about having secure access edge at the edge. Here's an example where somebody trying to get to Office 365, but in order to get to Office 365, the compute is somewhere else. It's not at the front door. With Zscaler, we have all the security stack at each data center. So when traffic hits the Zscaler node, it gets inspected at once and goes right out. So here's the classic architecture, and here's what it looks in a zero secure access service edge environment. Here you have your users, you have the proxy in the middle, the Zero Trust Exchange, and your destination. So think of this like a ring around the internet. So before you go anywhere, you must stop by the proxy, get inspected, and then based on policy, either you allow or deny to go where you want to go. And private access here, you have the legacy VPN design, which transforms into this design, where you have the endpoint reaching an application. You get authenticated by the third-party SAML first. Once you authenticate, then the policy gets checked. If you're allowed to go, then you have these connectors at the edge, which have a constant patrol plane, TLS tunnel to the brokers. And based on where the nearest one is, a full end-to-end TLS connection is made for traffic to flow through. And having all that, the third part of the product is a digital experience where we do have visibility at each location and endpoint to quickly isolate problems. This is what it looks like on the endpoint. You do have one agent that does all three: the private access, internet security, and digital experience here. And how do you migrate? Here are the 3 steps that you need to do. Here's your classic architecture here. First thing you do is you have the applications move to the external cloud or data center, wherever they are. You enable direct access from your branch offices and campus and data centers to the internet, but you can't send traffic there because you don't have security there. All your security stacks are here at the old. Now you do the transformation where you have the Zero Trust Exchange in the middle, and all your workforce is here, and you have internet access go through the proxy, and private access go through the brokers to access internal applications with visibility for both. Let's take a look at the architecture for the SASE environment. As you can see here in a single tenant architecture, what our competitors are doing is grabbing the appliances they had in a rack in their data center, converting those into a VM machine, and putting VMs in the cloud, and placing data center in the cloud with VMs in a number of locations. So your firewall, IPS, load balancer, database, proxy scanners, they're all VMs. And to use more than one data center, policy needs to be pushed in a batch mode, so they have to be pushed everywhere. And the logs are scattered in every data center. Good luck troubleshooting, correlating the logs from different data centers here. When Zscaler was built, it was built from the ground up. Our founder realized that security must move to the cloud. We can't have the old castle and moat security when applications have moved to the cloud. So when it was built, the engineers built a 3-plane architecture, where you have your central authority here. This is where our policies reside. It's a centrally distributed policy. And all the threat feeds come here from our partners. So we have MD5 hashes, different signatures, IPS signatures, all get stored here centrally. For data processing, we have the Zscaler enforcement nodes that are 150 data centers around the world. Here's where the policy gets executed. They just download the policy from here and just execute. Similar to an ASIC in a router, for those of you who are firewall, if you know, if you've been working with ASICs. So let's take an example and do a walkthrough of what a data packet walkthrough looks like. You have your admin console here, which connects to the central authority, where you do your policy definition, administration, threat feeds, and so forth. So all is done centrally here. So the policy resides centrally. When a user, let's say in New York, tries to connect, first it gets authenticated by the IDP. Once we know who you are, then the Zscaler enforcement does a pull, not a push, a pull from the policy. Says, give me the policy for this user, this organization, since we're a multi-tenant architecture. You pull that policy and load it here only. Does not need to go to any other Zscaler enforcement node around the world. Once the user moves to another location or country, for example, let's say he moves to London, again, user gets authenticated and the policy now gets downloaded there. The policy follows the user. There's another advantage of having a centrally distributed policy. The policy follows the user, where in the legacy, when you have firewalls everywhere, you got to make sure those firewalls have the same policy. And that's not an easy task. What's inside the Zscaler enforcement node? You can see it's a 1U appliance. It has multiple instances inside which run the full security stack. And throughout the years, we optimized the software. And now we could do 12 times the performance that we had back in 2013. Now at data center 4, latest data centers have triple ISPs. You go up to 100 gig. We have 10 gig NICs now for the servers. So we have a lot of capacity that we can expand and do SSL inspection at scale. How do we get this ultra low latency going through a proxy? Because usually in the past, going through a proxy would take time, and it would be much slower than go through a next generation firewall. That was in the past. So here, as you can see, when you go through a traditional service chaining infrastructure, you'll have to go through each VM to execute the URL database, the antivirus, DLP, and then you go out. In Zscaler, when it was built, what we did is we put every engine connected to the same shared memory. So when the packet goes to shared memory, all the engines execute at once, and the packet goes right out. We have a layered approach to security. There's no such thing as 100% security. There's no magic bullet. So you have to have a layer defense system. Here's an example of, call this the security onion, where you have the content type, reputation, scanning, and SSL inspection occurring before traffic gets released. You have browser isolation, and even behavior analysis. You can actually scan the whole file if it's the first time. Let's take a look at the Zscaler Zero Trust Network Architecture. Here's where, if you compare it to somebody calling to a published number, and I want to call it, can call you because you have published a number, just like an IP address is published on the internet. When you hide the application, only authorized users are allowed to connect and call. Unauthorized users will be blocked. And again, let's compare users connected to the network versus apps. This is an example where a user is let in the building to go to a certain room. This is similar to putting an IP address on a device. It says go to room 23, but once you're inside, you can move laterally and go to any room you want. And then take anything you want and go back out. In a zero trust environment, when you go in, you get authenticated, who you are, you say where you want to go, and you get escorted and placed in that room. You shut the door, and you're not allowed to go anywhere. Once you're done, you get escorted right out. So there's no way for you to go look laterally anywhere else. The steps of how it works under the hood, you have three components. You have the endpoint client, the broker in the middle, and the connectors. So how it works, a user attempts to access an app. You verify who the user is, get the appropriate SAML attributes based on policy. You're either permitted or denied. Once you're permitted, the path is determined, which connector, where is the application located, and what's the fastest way to get there. Once you get the optimal path, you get end-to-end encrypted connection connecting the user. And the app connectors provide dynamic server detection here. So ZPA, Private Access, enables ZTNA, no longer requires access to the network or VPN, inside-out connections, so the apps are invisible. You cannot do DDoS here, application segmentation without network segmentation, and the internet becomes the new corporate network and connections are done by TLS microtunnels. As a summary, you have your users, use private access to connect to your internal applications, and secure service access edge for external applications. And when you really think about it, you can reduce this whole thing, what problem we're trying to solve, into a 2x2 matrix. So you have employees, partners, customers. They're trying to get to inside applications from inside to inside. And when they're inside, they try to get to the outside, which is internet. When you're outside, you're trying to get inside, which is your VPN, your legacy VPN. And then when you're outside, you want to go directly to the internet. So to accomplish this, you have Zero Trust Network Access for this, SASE for this, with one endpoint agent, determining where to forward traffic. If it's internal, it goes here. If it's external, it goes here. If it's external, it goes to SASE. And this is your Zero Trust Exchange. That's the end of the presentation. And now I'd like to go into NYIT industry partnership. The last couple of years with Dean Beheshti's initiative, we're able to get an alliance with Zscaler, and we offer the Zscaler certifications to NYIT students to get certified into Zero Trust Network Access and cloud administrators and professional administrators, which is great. You know, when you have your degree and a certification certificate, it's easier to get employment. So we offer internet access and private access. Once you get the credentials, you can take the courses on your own time and get certified. And here's the certification link. And currently we have 113 users actually from NYIT that are actually signed up, and a few of them, well, actually quite a few of them, got certified already. So this is a good opportunity for anyone that wants to be certified. Contact Dr. Beheshti, and he'll show you how to do it. And thank you very much. That's all I have for you.
Thank you very much, Larry. We do have a question in the chat. This person says that this is all fascinating and important to know. However, it raises concerns and highlights paradoxes in regards to individual user privacy, professionally and personal, and alternatively, accountability and traceability like cybercrimes. What is Zscaler's point of view as it relates to user privacy and its accountability?
That's right. I mean, privacy is very important. You can think of us as Big Brother. Because we record everything and we see who's going where. So for privacy, we do have obfuscation. So in other words, when we display the user, we don't show the name. We show only garbage characters, and only we must have maybe one administrator only that's able to unlock that. That's for legal and actually law enforcement times. When there's something that occurs, they will get a warrant and say, all right, let's see who this person is. That's the only person who can see that. But you can have that locked down. And we operate in certain countries that have very strict privacy rules, like Germany, for example. It's up to the company to decide how they want to use, if they want to turn off SSL inspection because of privacy. they can certainly do that. We offer the tools, but it's up to the company. And we do have a privacy group that we can work with, different councils. We are GDPR compliant for Europe and so forth. So yeah, there's lots of information there.
Terrific. We have another question. ZTNA and SASE for ZTE seem like it's mostly available and optimized for corporate level versus individual user. Is that the case?
I guess I'm not sure if they're talking about consumer or at home, like home-based. We are an enterprise solution for companies mostly. I'm not sure if that was the question, but yes.
Yeah, I'm not too sure that was the question. Okay. If anyone else has any more questions, you can leave them in the chat box. Until then, did want to ask, isn't a next generation firewall just as good as a proxy for web traffic analysis?
Yeah, I went over that. You saw that graphic where the next generation firewall is good, but it has limited buffer to actually look at data. And plus, when you turn SSL inspection on, the problem with it's very CPU intensive. So unless you have a very large box to do SSL inspection, the CPU is going to go through the roof. So the new firewalls have extra memory and all that, but still they cannot do what a proxy can do, where you have to stop the traffic, inspect everything, and then create a new connection and enable the traffic to go through after you inspect everything. So that's the limitation that the next gen firewall has.
Once again, if you have any questions, you can leave them in the chat.
Yeah, I saw we use VPN for home computer. Can Zscaler be used for, I mean, we don't have individual licenses that we can sell you, but I think there's a minimum of 50 user licenses that you can purchase, and you can have your own tenant and have your own tenant at home, and maybe even give it to your friends and have them go through you, and you charge them for security.
Okay. It seems to be all the questions that we have for now. So I'll hand it back over to Dr. Beheshti.
Thank you, Sarah. So thank you, Larry, for a great talk.
Sure, my pleasure, my pleasure.
This was very, very interesting and very, as I said, timely. And also thank you all for participating in the event. My thanks go to colleagues who made this event happen. As I mentioned, Dr. Rob DeFazio, Assistant Dean Jane Polizzi, Ms. Carmen Marmo Savinetti, and our own Ms. Sarah Sasta. Please tune in for the next talk, as it will be advertised through the same channels. You learn about this talk. And thank you again, everyone. Have a great afternoon.
Thank you.